Hello, this is Group 6. We are using agent-based model to infer the information dissemination and the social influence on Twitter.
Our group project is about how information diffusion process is affected by Twitter user behavior, and we will use ABM as our method to build the interactive structure of user. Compared to previous model, we use PageRank algorithm rather than psychological theories to model human behavior. Also, we choose ABM rather than BA model, so we can design the type of agent and their interaction. The behavior of Twitter users in accepting and sharing information have a substantial influence on the effectiveness of information dissemination. Therefore, the individual social influence can be affected. Accepting and propagating information involves deciding whether to accept or reject the content and whether to share a tweet or not. The efficiency of information dissemination refers to how quickly the information spreads across the network. Individual social influence refers to the roles of individuals within the information dissemination network. For example, they could be the major influencers or just a information receiver.
For our model, we have used choose net logo for its ease of use, variety of model library, and visualization capability. And our objective is to simulate our hypothesis and visualize it. And now we have choose the PageRank model from the model library for its algorithm and the format design. After we have chosen the model, we have developed our model interface as shown in the figure. And we have one setup environment and which the environment can be set up and connection. And we have two go buttons, and one is for call the functions for once, and another one is for rapidly call the function to update. And we have a slider for adjusting the dumping factor, which will be elaborated in the later. And we have a show page rank switch, where you can see from the picture below, where the page rank number can be shown. And we have a plot, and the plot will show page rank of all user types. For the actual design, we have used the real-world data from the article, which you can see from the right-hand bottom corner. And we have scaled down the real-world data to 50, and the code, as you can see from the right, and the active user is set up to be 3, and semi-active is 4, inactive user is 10, completely inactive is 33. In our proposal, we think that the information spread process is the information spread among the user, which should follow the random walk diffusion process, which is the equation on the right. And by adding the D, which is the dumping factor, we can simulate the user behavior into information spread process, which is the PageRank algorithm. And for our topography, each agent represents as a node within the network, and the model defines a grid called page, with each page having a property like user type and page rank. And we set up which initialize the environment and sets the page shape to a circle and create the page, and based on our user active level, and assigning them to a different specific color. For active, we use red, and semi-active, we use yellow, and inactive, we use blue, and completely inactive, we use green. And each assign also with initial page rank value. The model sets the connection with the probability between agents to simulate the network structure, reflecting the nature of social interaction, where some users are more connected to others than others, such as the active user are more connected than the completely inactive users. And for our social network, we're following a power law distribution. Is a skill-free network, which is a skill-free network, and probability are set accordingly, where the active users have a 80% likelihood and semi-active user we use 50%, and inactive user we use 30%, and completely inactive user we use 10%. For the percentage of the likelihood, we came up and deduced that the likelihood is more likely for the active user, and with that logic, we set each accordingly.
In this part, I will introduce the independent variable in our experiment. In our experiment, we will change a factor called the dumping factor, and this one is original from the PageRank algorithm. In the PageRank algorithm, the dumping factor represents the probability that a user will continue browsing web page rather than jumping to a new page. However, in our research, dumping factor will consider as a user's behavior, such as how they responding to the information, like reject or accept the information in the social network. Therefore, they will be considered in the Twitter network spreading process in our experiment. To be more specifically, I will show you the mathematical equation for the whole process. Just like we mentioned before, the user behavior in spreading information in network will follow a diffusion random walk process, and this process could be described as the following equation. What's this meaning? This means the importance of user I at the time n+1 will depend on its neighbors from the times n divided by the user I's outlink times the adjacency matrix. The adjacency matrix is a description for the social network structure. If user I is connecting to user J, we simply pick 1. If they are not connecting, we just simply pick 0. And by adding the independent variable D in this equation, just remember that D is a probability, and it represents the probability of user rejecting information from the neighbors. So 1 minus D represents the user do not reject the information from the neighbors. We will show you this one in the example. Observe this user. If this user wants to spread information, it will directly to this user and this user just simply because they got a link to each other, and this one is a direct link. So the probability of these two users receive the information will be D divided by N, and for other user in network will just simply be the 1 minus D divided by N. Therefore, by adding the two information into this process, we will get the whole equation just look like this one, and we will use this equation to describe the information spreading in our experiment. Now come to the experiment design and the evaluation part. In the experiment, we will use IBM simulation in NetLogo, the experiment arm to simulate information distribution in the multiple random network with different dumping factor D, where D is in the range of 0 to 1. We will adjust D in the value of 0.05, 0.1, 0.15 to 0.95 by adding each one just by 0.05. And the test will be repeated for 20 trials. Why we need to repeat for 20 trials? Because in each network, its structure is being randomly created by the connecting probability we stated in our code. So if we only consider one type of network structure, the outputs would be very accurate. And also, the PageRank value for each node will be recorded and calculated into the mean value. The time step will also be recorded. But now we come to the question, when should we stop? We stop when the time step required to reach a steady state in Twitter network in each trails. The steady state meaning is the information finish is spreading, and it also could be described as the following equation by the PageRank value of users. This meaning is user J, the PageRank of user J at the time n+1 equals to the page value of user J at time n. When this one is equal, we call the network is in the steady state, and this is the time we should stop. We expect our experiment providing the result is the importance of main influence decreasing as D getting smaller. This might be because of the user engage more with a different type of user in the Twitter. And the second one is as a D decreasing, the converge rate of a network reaches steady state improves, vice versa. We will come to these two expectations because when you analyze the algorithm and we think about if we get a D very small, just like D equal to 0, the equation just becomes 1 over n. So the PageRank value of the user I will just depend on the whole network, how the users in the number of users in the network, and it's worth the information from user I was spreading equally and easily. And if we think about the D is equal to 1, it's a very large number, and the equation becomes this one. This means the information spreading is very depends on the network structure of the user I. If the user I connecting with its neighbor in this spreading, and if they are not connecting together, they are hard to spreading information from the neighbors. So it will take time. So that's why we come to these two expectations. So this is how we do our experiments. We can say we got a plot here and the network structure here. The plot just shows the different type of user, the mean value of a different type of user. It's easy for us to observe. And this is how we're gonna do the experiment for the 20 trials. As we can see, the dumping factor is increasing by the 0.05, and everything we're gonna record it by the mean value of each type of user. The mean PageRank value becomes the table of that. So now we are gonna do our data analysis. So we take the mean value for 4 types of agents in 20 trials. Just like this. So everything is listing number right now, and now we're back to our question. When should we stop? You may observe that here they got a similar PageRank value, so we consider the structure becomes steady state at time step equal to 10. But this method kind of silly because we need to use eyes to observe. So now we're back to our question, what are we actually measuring? We're actually measuring is when the information stops spreading. So now we're gonna say here is a tendency because of the PageRank value that are actually decreasing. Now we come to think about this one is actually a rate of change over the time. So we can represent the tendency by the rate of change, just basically compare to the rate of change with respect to time. What we are going to do is we will plot the mean PageRank for the users to the time step reach to 500. This one is for active user, and we will pick up the different dumping factor, just pick up the rate of change of them. And this is whole things. We will list the different dumping factor, pick up the rate of change, and list it below, and do other linear regression. Same thing for semi-active user. Same method for inactive users. Same method for completely inactive users. For active users and semi-active users, we use a linear regression, and the R-square is relatively high, so that is real fit could be accepted. And we may observe that D equal to 0.2 and D equal to this number for active and for semi-active is gonna be the fastest information spreading. And with D increasing, both the tendency shows that the time of the information spreading will also increasing. For inactive and complete inactive, we're going to use the quadratic regression. R-square is relatively high, that is well fitted. And for the D equals to this 3 value, we're going to reach is a faster information spreading. Also, we're going to consider is a critical value, which is in this part with a D increasing. With a D increasing, the speed of information also increasing, but past the critical point, with a D increasing, the spreading of the information is decreasing. Now we come to the social influence of user part. You may observe that with D increasing, the active user counting the highest PageRank value, whereas other users is gonna have a low social impact. And there also got the interest found is that the complete inactive user gonna have a large social impact with a low D. It's not because of the people don't really like to reject the information, and the complete inactive user is counting the highest amount of user type in the network. So that's why they're gonna counting the highest social impact with the low D. Now we should consider the result validation. Does our model answers our hypothesis? Yes, the time of threading change with a D change, and also the social impact change with a D change. So our model is to be proved as success.
The possible development of our project includes dynamic network scaling. We could simulate network growth where new connections are constantly formed, just like the number of followers increases in the real-world social media. The user preferences can also be added to our model. We could define user-specific preferences for different types of information, such as art, technology, or sport. Building a more realistic social networks is another direction. We can divide users into smaller close-knit groups, allowing for more frequent interactions between group members.